Hello everyone, welcome to the talk. Today we are going to talk about flowing things.
Please turn off
So
your
the title
mic.
of the talk is Flowing Things,
fine,
Not So Strange in the MVI World. This talk is about the newly introduced Kotlin Coroutines Flow framework and how we can achieve a model view intent pattern using the Flow framework. So I am Garima Jain and I work for a company called Over as an Android engineer, and I'm also an Android GDE from India. Who is this talk for? So if you're coming from Rx background, if you are interested in coroutines, or if you have started using coroutines, or you're just starting to use coroutines, if you are also interested in using this model view intent pattern, or if you have seen this show called Stranger Things, then perhaps this talk is for you. So what is this talk about? So we're going to divide this talk into 3 chapters. The first one is going to be a brief introduction to coroutines and flow. The second one is going to be a brief introduction to this model view intent pattern. And in the third chapter, we're going to take an Rx model view intent pattern and try to convert it side by side to use the Kotlin Coroutines Flow framework. And finally, we're going to summarize everything. So this brings us to the first chapter of this talk, that is the flow. So in order to understand flow is based upon coroutines. Let's talk about coroutines a bit. So what are coroutines? Coroutines are lightweight threads. Coroutines run computations without blocking a particular thread, and coroutines can suspend at a particular suspension point and can be resumed from that particular point later on. So there are various concepts attached with coroutines. The first one is scopes. There are various scopes. So scope, as the name suggests, it is the lifetime of a coroutine. So there are various scopes available to us out of the box. First is the view model scope, and then there is something called lifecycle scope. Lifecycle scope is available to us for any particular lifecycle. For example, activity or fragment, we can use this lifecycle scope to create a particular coroutine, and it will automatically be destroyed at the end of the scope. Then how we can create coroutines, and for that we have coroutine builders. There are various coroutine builders available to us. The first one is the launch coroutine builder, and we have another one called async coroutine builder. So launch is a fire and forget kind of a coroutine builder. We can use this coroutine builder to launch a particular coroutine if we are not interested in the result. But if we're interested in the result of this particular coroutine, then we need to use this async coroutine builder, and whenever we'll call .await function on this particular coroutine, then we'll get the result out of this coroutine. So there is another interesting concept attached with these coroutines builders. These can only be called from a particular scope. So that means we can only create coroutine within a scope, which is called structured concurrency. So in the initial versions of the library, coroutines library, there was no notion of the structured concurrency, this concept, and it was introduced later on. Because even though coroutines are lightweight, we still do not want to be creating these coroutines and can just forget about them. We need to scope these coroutines because they might be holding on to some important resources that we want to dispose of. So then there is another concept called channels. So if we have now multiple coroutines, how do we communicate between these two different coroutines? And for that we can use these channels. So what are channels? Channels are something similar to a blocking queue, wherein we can put something, and whenever we put something or send something inside this channel, we're going to suspend until there is a receiver on the other end available to receive from this channel. Similarly, if the receiver comes in first and starts to receive some values from this channel, the receiver is going to suspend until a sender is available. So then there comes the flow. What is flow? Flow is actually cold asynchronous stream of the data. It is much like reactive observer, wherein we can sequentially emit values and subscribe to those values. Flow utilizes coroutines and channels internally. Flow APIs became stable since coroutines version 1.3.0, and now we're at 1.3.5. That means there has been quite some time since these APIs have become stable. So let's look at a few flow builders and how we can create flow in various manners. Firstly, we have this operator called flow of. We have this another operator called flow, which takes a flow collector and we can emit various values into this collector. And then there is channel flow. We'll come back to channel flow later on. So we have various operators like intermediate operators, map, filter, take, zip, etc. Just like Rx Java observables. And we have a few terminal operators like collect, single, reduce, etc. So let us look at a code snippet for flow. What we are doing over here is we are going to use this coroutine builder to create a coroutine, and inside that we are going to create a flow stream. So this flow stream is created using this flow builder, wherein we loop over the values from 1 to 10 and we send various values, we emit various values into this flow. And so we're going to emit all the values from 1 to 10 sequentially with a delay of 500 milliseconds, and then we're going to filter out all the even values using this filter operator, and finally we're going to collect all the values from this flow and print them. Let's try to run this code snippet. So as expected, with a delay of 500 milliseconds, we are printing out all the even values. So there are a few concepts which are important when we want to understand flow, and the important one I want to highlight over here is the context preservation. So when we want to talk about context preservation, let us look at this code snippet. Firstly, we create a flow of these three values 1, 2, 3. We map it and add 1 to it, and then we attach an operator called flow on, like subscribe on. Not exactly like subscribe on, but like something similar. We'll talk about it. Then what we do is we take this flow and we filter out values only which are equal to 3, and then we have this another construct which is more like we want to change the dispatcher of this particular flow, and we set it to main so that like we can execute a few things on the main thread. So what happens is, like, this map, because of this flow on, it is executed in context A, and changes in the upstream, that is flow off and map, both of these are executed on context A. And this filter one is actually a pure operator without a context yet, and all the non-encapsulated operators will then be executed on main, that is filter, and that is this one filter which is a pure one, and the rest of the stuff. So everything else is going to be executed on the main thread. So if you can relate this particular concept to a real life Android problem, what happens is, like, for example, you want to hit an API call and you want to schedule that particular API called on IO thread. With Rx Java, what happens is you might use .subscribe on to do this, and with Rx Java, it happens that, like, that particular context, that particular scheduler thread leaks out of the data layer into our because everything that is downstream from that operator, everything is then executes on the IO thread. But that is not the case with coroutines. The context is preserved upstream and the context does not leak downstream. So this is an important context and a slight difference between observe on and flow on. So this brings us to the second part of the talk, that is the battle of actions. So this part is about model view intent pattern. So what is a model view intent pattern? As I like to say, it is also called like this: model is state and intent is the intention of user to do something. So there are 4 various constructs over here, that is state, intent, user and view. So what happens is user intends to do something, it interacts with our view. Intent causes a change inside the state, and that state is then shown on the view, and this view is shown to the user. So any change in the state is only caused by an intention from the user. So this is a basic depiction of MVI pattern on top of MVVM. We have a view over here, we have a view model, we have a reducer, and we have this data layer. What happens is we send it an intent into this view. View sends various actions to the view model. These actions are converted into one or more results. These results may or may not make use of data layer or like external resources. All these results go inside the reducer, and reducer takes in the previous state to create a new state, and then this new state is observed by the view. So this is the unidirectional cycle of model view intent pattern using this view model MVVM, like MVI on top of MVVM. So what we are going to do is we're going to look at these various pieces. The first one is view sending various actions to the view model. These actions getting converted into one or more results, stream of data. The reducer takes in the previous state to create a new state. Then this new state is observed by the view, and then finally plugging in all these pieces inside the view model layer, that is creating a cycle. So to mention all these 5 parts again: action, events, converting action to results, reduce the results to the new state, state stream observed by the view, plugging in various spaces inside the view model. So this brings us to the 3rd chapter of the talk, that is vanishing of Rx flowables. So in order to migrate an existing Rx MVI pattern to use flow, let us try to take a look at this example. So we have a loader, load data, then we get these list of characters. We can scroll through and we can click on a description for a particular character to get the detail of that character and so on, and then we can also hit pull to refresh on this particular view. So let's try to model all the actions in this particular example. We have various actions like load data, pull to refresh, load description for a particular character. So with Rx, what would happen is we would have a view model interface wherein we can call this on action function and pass in various actions. This basically remains the same because it is an interface, it has nothing to do with streams and flow. So what we can do is inside our view, we can directly call on action on this view model and pass in various actions, like we can attach a listener and pass actions and so on. So basically we already converted this particular first part and we're happy because we didn't have to do much. That brings us to our next part, and I will ask you to not go into too much detail into this all the code, and I'm going to highlight wherever a particular line of code is important. So here we have a result interface, min result. So for each particular action we have one or more results. In this case we have 3 results. For example, for loading we can emit a result of loading error or loading completed with a list of characters, and similarly for pull to refresh and description. So in order to look at conversion of actions to result, we need to split our data into 2 layers, that is repository and network. What we are going to do is we're going to hit the API that's going to be on the network layer, and on the repository layer we are going to hit the network. We could also introduce a cache over here behind this repository layer, but for simplicity's sake we're not going to take a look at the cache in this particular example. So our data layer with Rx Java, this is how our data layer, our retrofit repository would look like. We would have a get character single, wherein we are going to return a single of a list of characters. Then our repository would be straightforward, use the API to get this character single. So with Rx, this is how inside our view model we're going to take a flowable of actions, that is stream of actions, and convert each action into one or more results. We're going to take the stream, we're going to observe on IO thread, we're going to flat map, and for each of these actions we're going to fetch characters, because this is load initial data. We're going to map it to loading complete. We're going to start with the loading result, and on error we're going to navigate to show a snack bar or some error or something, and we're going to map this one to a error result. So this is our Rx implementation. So let's start with data layer and convert. This is going to be the first interesting part. Convert this to use flow. So if you remember, we had this function returning a single of list of characters. With coroutines, what we can do is we can attach a suspend function over here, and because of retrofit 2.6.0 we can do this as it is available out of the box. And if you notice in detail that instead of returning single of list of characters, now it is returning a list, the list of the characters itself, the data itself. So this becomes a little bit sequential. And the next thing is our repository, because I said that only for this repository only our API is concerned. So we can in this case also we can convert it to use coroutines. We can attach a suspend function and return the list of character itself, which basically hits the API and get characters. So next is the view model, that is converting our various actions to results. So the first action is load data action, and we just now saw this implementation. Now let's try to convert it to use flow. So what we will do is, like, now we'll go line by line. This is very interesting. Like so what the previous function took actions as a flowable of a stream of actions. We convert this to use flow, and then we return, instead of flowable we return a flow. Instead of this actions we have actions flow. We instead of flat map we have flat map merge. So with this Rx, our repository was returning a flowable, but now our repository is returning result itself, so we convert it to use flow. We can use map, which remains the same. Start with becomes on start, on return becomes catch, and it is more or less a similar kind of a stream. So for poll to refresh, we can do a similar thing and convert it to use flow from Rx. And similarly for description also, we can convert this flowable to be flow instead. So with Rx, what we would do is, we have a particular stream of actions and we want to convert it into a particular stream of results. So in Rx, what we usually do is, we bifurcate our action stream based upon various actions. We convert those actions to result, and then we merge these streams back. So over here, the important part is this merge operator, because the rest of the things are more or less the same. So this merge operator, let's try to have a look at this. So when I was writing this for the first time, there was no merge operator at the time. So and creating operators with coroutines is comparatively easy. So I decided to create one also for learning purposes. So let's try to create one. So this is a basic implementation of merge operator. We have created an extension function over this flow, and we taken another flow. We want to merge these flow into one, so and return this merged flow. So this takes in a channel flow. We'll come back to channel flow, but just know for now that we're using a coroutine flow builder and creating this flow. What we do is, we launch two particular coroutines simultaneously, and we collect from the current flow, this flow, and we collect from the other flow and send it to this channel flow. So we're collecting from this we're collecting from the other and sending all these values into this channel flow. So over here, multiple coroutines are involved, and if you remember, when we want to communicate between two different coroutines, there is something we need to use, that is channels. By default, two different flows cannot coroutines cannot communicate unless we have a channel in between, and that is why we have used a channel flow over here. So we have successfully created our merge operator. So with Rx, what we have done is, like, this current flow implementation is very similar to Rx. Like, we have a stream of actions and we convert these streams of actions into results. But what we can also do this is, we can utilize the power of coroutines a bit more. So if you remember, our repository was actually exposing the list of characters as the data itself. Like, there was no stream like something going on over there. So what we can do is, like, instead of bifurcating the action stream and then merging it back, what we can do is, we can make it a bit more sequential. So what will happen is, for each action, we're going to load we're going to create a flow, big flow over here, and if you notice, this code becomes a little bit more sequential. We inside this flow, we will emit loading, then we'll get the characters, we will emit loading complete, and in case of error, we're going to emit loading error. So this becomes a little bit more sequential. So if you remember, I said that, like, in our example, there is nothing stream like going over here, but and our repository was actually exposing the data itself. But in some cases, what could happen is, we could be observing some kind of database in the repository layer. So in that case, our repository might not return the list of characters directly. It might be returning a flow of characters. In that case, we need to go with the previous approach that I just mentioned, wherein we bifurcate actions, we convert actions to result, and then we merge it back. But this totally depends upon our use case. Like, if you have a particular use case which is quite simple and we are not worried about observing the database, then we can simply use this approach, which is a bit more sequential. That is, this was our Rx approach, and everything was a stream over here in the logical side. This will actually become quite sequential and direct if we use coroutines. So if you do not have a complex scenario and you can convert your repository layer to return data itself, then you can fully utilize coroutines approach over here. Or what you can do is, like, if you want to observe results from the repository, you can take a return flow of something from the repository layer and observe, and then keep doing your Rx kind of reactive kind of pattern over the presentation layer, inside the presentation layer. And we can do this from Room 2.2.0 alpha, because that introduced flow support, and now we can observe flow from the room itself. So this brings us to the end of this part, action to results, and we're quite happy that we have successfully migrated all our actions to results. So the next part is reducing results to new state. So this is our state. Let's not go into the detail of the state, because we're not here to talk about state modeling. This is our reducer. So reducer is a function which takes in a result and returns a new state. Need not go into the details of this as well, because it is a pure function, everything remains same, and there's nothing stream like going on over here. So we have already converted our reducer, and because it remained the same, we're happy. So the next part is state stream. That is, our view observes our state stream. So again, we have our state over here, and in order to do that, what we're going to do is, we are going to expose our stream of state inside our view model. For that, we create a new live data, mutable live data, and whenever the state changes, we post various values into this live data. And on the view side, we observe this live data and attach it to the lifecycle owner, and finally call the render function. So with coroutines, there is something called conflated broadcast channel, which we can also use. It is not mandatory to use this in this case. Live data is perfectly fine, but let's talk about a bit. So what we'll do is we will create a conflated broadcast channel for the state, and we'll expose it as a flow from the view model. And whenever the state changes, we'll offer the state values into this channel. And on the view side, we're going to collect from this state, and we're going to call the render function. But this collect can only be called from within a scope. So we have this life cycle scope available from 2.2.0 alpha 2. So we can use this scope from within any kind of view activity or fragment. We can use this scope and launch a coroutine which collects from this view model. So this is also an approach instead of live data. But let's talk about conflated broadcast channel. So as the name suggests, because it is a broadcast channel, it has multiple receiver, and conflate means combines. So what happens is, if we emit multiple values into this channel, then it is going to emit only the recent value, and it is going to combine all those values, and it is going to emit this recent value to multiple receivers. So this is conflated broadcast channel, which is very similar to Rx Java's behavior subject, if you remember, which saves in previous value. So this is a basic render function, which is also a pure function which takes in a state and does a bunch of things on the UI. Not too important because it remains the same. And this also pretty much remain the same if you do not consider that conflated broadcast channel change. So finally, now it's time to plug in all these pieces and create a cycle inside our view model. So let's begin with the last part. That is, inside our view model, if you remember, there was this interface, and we need to implement this particular onAction function. So view can call .onAction to pass in different kind of actions, and those actions need to create a stream. So with Rx Java, we can create a stream using this publish processor, which is nothing but a subject. So we create this publish processor, and inside onAction, we just pass in all these actions inside this publish processor. As just mentioned, this can be achieved with coroutines by using this conflated broadcast channel, because it also behaves as a behavior subject. So whenever there is onAction, we offer various actions into this broadcast channel, and we expose this channel as a flow. So we just converted we just created a particular stream of actions. Now, how do we plug in various pieces inside this Rx view model? So we have these stream of actions. We already looked at action to result transformer, that is converting all the actions into their corresponding results. We have the scan operator, which saves the previous state and takes in a new result and calls reducer function on it. And then we subscribe to all these state values and post these values to this live data. And finally, bind to lifecycle is an extension that we have created over this observable, which basically binds it to lifecycle. As the name suggests, it creates composite disposable under the hood and disposes it off when the lifecycle of this view model ends. That is on clear or So let's try to now convert this Rx view model to use flow. So let's come back to this launch later. So this processor is actions flow, action to result transformer, we already converted. Scan operators remain the same. Dot subscribe becomes dot collect, and this bind to lifecycle as actually scope. The scope is as we talked about it earlier. It is the scope wherein this particular coroutine lives and it gets disposed of, which is similar thing as using composite disposables and disposing of all the disposables inside this. So we have successfully converted this particular cycle to use flow. And congratulations, you have migrated your Rx MVI pattern to use flow. And this brings us to the last part of this talk, that is the summary. So what did we learn? So on the Rx side, if you have something like a single or a completable, you can use suspend functions instead of that. But if you have streams, if you have multiple data being emitted over time, then you can use flow. And if you have behavior subject, we have something called conflated broadcast channel for that. Schedulers are dispatchers, disposables are scope, and so on. So these are various operators which can be mapped. I am going to post these slides and you can have a look later on. There's also this thing to keep in mind, that subscribe on is actually not related to flow on, and there are subtle differences which we talked about. Also, let's try to answer basic common questions which I come across. So the main question is, why do we use flow? We have Rx Java where everything is working fine, and the current state of flow. And to this, I usually like to respond as like, flow is the shiny new thing. Like we already have Rx Java and we want to use flow. But jokes apart, flow has first party support because like coroutines. And now various Android libraries have started having flow support like Room. And by using coroutines and flow, we can reduce the complexity of business logic even further. We can make things more sequential, and hopefully Kotlin multi-platform share business logic in future. So Rx Java coroutines interop, yes, coroutines interop is available by using this library, and we can call various await and await X functions and all those things. So if you have a non-coroutine API, like your API doesn't yet support coroutines and you want to convert, yes, there is like something called suspend coroutine available, and you can call .resume with and resume with exception over these. Testing support, yes, we have something called test dispatcher, which behaves very similar to test scheduler, and you can advance time and all those things you can do. And you can set your main dispatcher using this, like we have testing support.
Okay,
And perhaps inject your dispatcher provider if you have
Maybe you can
done a similar pattern of injecting a scheduler provider and all those
That's
things.
perfect.
So what is next from here? So there are various like references that I've pointed out over here, and there is also a demo project which I have created and uploaded on this link for this talk, which you can go and check out. And for references and acknowledgement, I really want to thank a few people, for example Manuel Vivo, Hennes Dorfman, and so these people have helped me in reviewing the particular code for this talk, and my husband Ritesh Gupta, who has made sure to attend all the talks regarding this and review all the content which I've posted. And finally, thank you, and I would love to get some questions.
Okay. Questions. Go live.
So let us look at some questions now. Thanks for asking these questions. So let's talk about the first one. Thanks for the great talk and excellent presentation, slides and skills. Could you share the demo project and slides? So I've already uploaded the demo project on my GitHub, and I'm shortly going to share the slides after this talk. You can also keep an eye out on my Twitter, that is @ragdroid over there as well, and you should see there. And we're also going to upload those to this platform of Android makers. Next question is, what do you think of the error handling in Flow? Is it as easy as with Rx? So most of the concepts are pretty much similar, but you do need a bit of coroutines knowledge. So there is something called like the concept of job and supervisor job. So a bit of knowledge of coroutines is also required, and that would help us in understanding better. So the next question is again about the slides, so we're going to share it. And the last one is great talk, thanks, explains very well the concept. Would you propagate using flow instead of live data inside your view model? So I think I mentioned it for a bit inside the talk, within the talk, that we can propagate our state from within the view model to the view. So it is up to us. I chose live data because of life cycle, and lifecycle awareness, and we can very well do it using Flow. It's again up to the implementation. So the next question is, thanks a lot. Do you really have the feeling that Flow is simplifying somehow the code you would have written with Rx in the end? Both seem to be quite similar. Yes, both seem to be quite similar, and I do think Flow is simplifying because, like, as I like to say that, like, not Flow, coroutines make our logic a bit simpler because it makes it look sequential. So if you have a place where you're using single or a complete table, you can instead just do with using coroutines. If you're not dealing with streams, then you can just use coroutines and make that code a bit simpler. So your logical side becomes a lot more simpler with coroutines and Flow. So the next question is, would you use custom scopes or view model scopes for flows? I've mostly used view model scopes and lifecycle scopes for now. I haven't had to create much any custom scopes. If I would say that, like, try it out and use a view model scope if you want to launch a coroutine from within a view model. If you want to launch a coroutine from within the view, use lifecycle scope. But if you still feel that, like, you would want to achieve something wherein you need a custom scope, then I guess. So I mostly didn't have to use custom scopes, but yeah, like, I'll share somewhere on Twitter or something if I come across a scenario wherein custom scopes are needed. So in the next question is, in Flow, who controls the dispatcher on which the action to results operations are executed? So we can control the dispatcher. We can use Flow on operators. So in my example, the only thing that I wanted to execute on a background dispatcher on the IO thread was API call. So for that, retrofit, it internally handles the dispatcher and it doesn't leak out, but that gets handled and API calls get executed internally inside retrofit. So the next is, are you aware of operators that are easily available in Rx but not yet in Flow that might make the transition to Flow difficult? So for basic use cases, it has been pretty smooth until now for the transition. I've seen a few people talk about multicasting and sharing. So that is not yet available out of the box. We can do it somehow with channels, but yes, like, they're working on it, and there is already a proposal for adding a subject, something similar to subjects on Kotlin coroutines. So the next question is, did you have limitation in Flow with operators like zip, combine, latest, or with concurrency? I don't fully understand the question, but, like, initially when I started out really early, there were a bit limitations. For example, there is another operator, like, which I had to create myself. It was like off type, which is used to bifurcate the stream. And at that time, there was also this merge operator. Most of the operators are still available, and there is, I think at that time, David Karnock, the main contributor of Rx Java, also created a repository which filled in the missing operators. So overall, the whole package was there for me. But then later on, they have added more operators, and they keep on adding these things. So, like, yeah, we should have more operators, and we already have a lot of them, according to my use case with what I have done till now. So I guess these are all the questions. If we do not have any more questions, then thanks again for joining the talk and taking out your time, and good day to you all.